I'm Don Toporowski, and this is the ReThink Mining podcast. Today we have Spencer Aertker from Eden GeoPower. We're going to be talking about how to break rocks with electricity. It's a fascinating technology, and I hope you'll stay with us. Welcome to Toronto and welcome to the studio today, Spencer.
Happy to be here.
Since I started at ReThink Mining about 10 months ago, I've probably looked at 200 or 300 different technologies that were interesting to our members. These members are the 20 biggest and most innovative mining companies in the world. But the one that kept coming up was Eden GeoPower and using pulse power to break rocks. And I found it interesting, but I didn't really look at it closely until Katie Holm from BHP came up to me in Vegas at Mine Expo and said, I need to introduce you to Spencer because they have a fantastic technology. And I think ReThink Mining can help us advance it and bring it to commercialization. And then a funny thing happened again last week. We brought all the members of ReThink Mining together in Toronto to talk about what are the issues they want to address most. What are the ones can they work on together? And Eden GeoPower kept coming up again. So we're going to be bringing them together next week to talk about how to support you. And I'm so happy that you're here to share a little bit about your company, where it's going, and to inform the people who might not be in that meeting about the progress you've made. Tell us first what is pulse power? What is that thing?
So pulse power is essentially discharging high voltage electricity into an ore body. As far as we know, back in the 70s with the Soviet Union, and then they were developing it to do comminution XC2 on the processing side. And essentially what it does is it breaks apart ore by two processes, one being material failure, or which we call internally grain boundary disintegration, and then two also by shock waves, which basically just fragments the ore. And why it works so well with ore that hosts these critical minerals is because of the unique properties. So you have these very conductive sulfides that typically host copper, molybdenum, zinc, and they're very conductive. And they're in grain boundary contact with non-conductive minerals such as quartz. And when you have that property of contrast and conductivity, pulse power actually works very well to fragment the ore. But it also has other benefits that are known. It makes the ore weaker, so you decrease the bond work index, which makes it easier to grind during the comminution step, which is a pretty energy intensive process. It also has another unusual component is that because the fracturing occurs along these conductive uh, critical minerals, the fracturing preferentially occurs along sulfide veins or sulfide grain boundaries. So it enhances the liberation of metals, and it also has another effect of breaking apart those sulfides, which you would get smaller particles than you even would in the grinder, so an even better particle size distribution.
Tell us about your work with BHP and the Department of Energy, who were looking for ways that you could validate the technology and increase the mining industry's confidence in us. What was revealed in the work with those two organizations?
So I'll start with the federal funding we received. So we receive funding from an agency called the Advanced Research Project Agency for Energy within the United States Department of Energy. And that's essentially their high risk funding agency. So they target high risk but high impact technologies that say, well, if this is successful, this will have a huge impact on energy. So in the case of Eden, they awarded us 3 contracts. So starting from the beginning, the first one was to break rock for geothermal applications, and that was awarded in 2021. And then we were awarded a contract for in situ leach mining, in 2022 out of the miner program, which is one of the first mining programs to come out of Department of Energy in a long time. And we work um, with national labs, so PNNL, INL. We work with academics, Colorado School of Mines, Massachusetts Institute of Technology, Stony Brook. It's a pretty large team. And then we were awarded in 2023 a a contract to fracture iron-rich formations. And they were interested in fracturing iron-rich formations because these formations can also generate hydrogen. So there's been some investigations into the viability of geologic hydrogen as a resource. So those are the three funding opportunities we have with DOE, and they amount to around, I believe, 6 million, which is pretty impressive for a startup. And then we also worked with industry. So we worked with the New Lab Mining Studio in BHP, and that work started in 2022, and that's where Eden's proposed this idea of pulse powering ore in situ. And uh, BHP and New Lab supported the lab scale pilot, and that work concluded, I would say, about 6 months ago. And then we were also awarded funding with the Think and Act Differently, powered by BHP for in situ leach mining. And we worked with the JV there and tested what would be the uplift in yield leaching ore in situ, and that work concluded in January.
I know BHP is really enthusiastic about your technology, and I hope we can get some other miners who are members of ReThink Mining to join them in supporting you as you continue forward.
Absolutely. No.
So I had thought the main benefit of it was reducing energy and comminution, and the studies show, I guess, that it could cut the energy in half or more. But you were telling me it provides value all the way down the processing chain. So tell us about some of those different values that it delivers.
Yeah, since Eden deploys pulse power directly into the formation in situ, so say on a rock face or a mine bench using, existing blast holes, it has more an effect from the bench to the leach pad. So more upstream, downstream effect during mining. So if you're able to weaken these ores in situ, um, there's a tendency that you don't have to drill as much for the blast hole operation. So less drilling, less blasting is required to get the fragmentation you want because the ore is already weaker. So that's less blasting. And then if you attain a better particle size distribution, you also have more efficient load cycle times into your truck because the ore is weaker, you have better particle size distribution. And because you have that better particle size distribution, you have more efficient loading into the trucks. So you move a more efficient amount of ore into the mill. So you have less diesel consumption. And then once it gets to the mill, the ore is already weaker because of the pulse power effect. So a lower bond work index, so less comminution requirements. And then because the fracturing has a tendency to occur along sulfide veins and sulfide grain boundaries, like in a porphyry, you also enhance the liberation or flotation step and make it more efficient to liberate those critical minerals from the gangue. And then because you also have the effect of cracking the sulfides to a smaller particle size distribution with pulse power, you also get the benefit of enhanced kinetics at the leach pad. So it does have this effect from the bench to the leach pad, and it's not constrained to just the processing, which makes it really unique and really beneficial to mining.
And I thought that the savings in energy alone was so significant that the technology could make a significant difference to mining. But you were telling me that the increased recovery rate actually provides a economic benefit that is greater than the energy savings.
Yeah, that's what our techno-economics indicate, that the largest value proposition is actually an increase in metal yield at the end of the process, not just the energy savings. A 1% increase in yield would be huge for the mining industry, and that would be coupled from, enhancing the flotation and leaching steps.
So, for people who aren't familiar with how your technology works, give us an explanation of how you would use it in an underground mining environment exactly.
So we've had a lot of interest in underground mining, and it could be facilitated by, deposits getting deeper and deeper. So that could be an kind of a motivation for the mining companies to deploy the technology underground. But the way we see it, it could be used for block caving, using pulse power directly into the ore body for block caving, but also to make mechanical cutting a more effective process, because hard rock ores are so hard that it currently makes it not an efficient process. And if we can decrease the bond work index to a certain threshold that's needed, it could also open up mechanical cutting as a viable process for underground mining.
Yeah, that was one that mechanical cutting in hard rock has been frustrating the mining industry for quite a while. And I thought that was one of the greatest chances to rejuvenate those efforts, try it with rock conditioning beforehand. Do you think the dream of conditioning the rock, using mechanical cutting, and then processing it underground, is that realistic?
It's realistic if you can decrease your footprint that's needed to do uh, the beneficiation process underground. So if hypothetically you're able to provide an ore with a lower uh, bond work index, and you're able to get those critical minerals more easily out of the ore, and you could do that on a smaller footprint, yeah, you could probably do it directly underground instead of having to have the process of hauling and bring it up to the surface, which is a time consuming process.
Yeah, that would be a big change for mining. So if we were to start using it underground, my understanding is you'd drill some holes, you would put in a couple of, I don't know what you called them, probes,
We call them just electrodes, or sometimes we call it the BHA.
and then describe the energy that goes through those and what happens to condition the rock in situ.
Yeah, so what makes this an interesting use case is that we just use the existing blast holes. So we're not asking the mining companies, you need to change your operations substantially to integrate this technology. It still is just a minor adjustment to the process flow. So we would just insert the electrodes into the existing blast holes that they use traditionally. Our current field scale devices, they discharge 400,000 volts, which is pretty substantial, and we discharge it in increments into the ore body. And as you do that, you start to basically disintegrate the ore, or what we call grain boundary disintegration. And then once you get to a certain point, you can start generating shock waves in the ore body itself, and that's another component we add to really fragment the ore. So we would just do it directly into the rock face.
And after we condition it, would we blast it then?
So right now, we see this as a tool to enhance blasting, but we hope one day that it's de-risked to a point that it can actually replace blasting, because there's a lot of benefits there that we can do with pulse power you can't do with blasting. There's a lot of directional control with the fracturing that you can't do with blasting.
And if you put the pulsing in it long enough, you can basically crumble the rock.
Yeah, I mean, we've
Put
seen
it
it
go
turn to powder.
Yeah,
If you're so inclined, you can do that.
yeah.
Yeah.
So you have a test coming up at the Colorado School of Mines. Tell us about that.
Right, so, the Colorado School of Mines has an experimental mine called Edgar Experimental Mine, and it's a really unique opportunity because it allows us to easily do tests at a mine, which is not easy to find because there's logistics issues or safety issues with active mines. So we will be starting tests April 1st, where we will be doing first outcrop tests. We'll be pulse powering outcrops. That's basically to make sure that the pulse power devices are optimized before we move to what we're calling the surface wells. There's a series of surface wells there. Some extend down to 100 meters, which is pretty deep. And we'll be doing pulse power tests downhole at different depths. And to determine if we are creating fragmentation or fraction networks in that ore body, we'll be doing injectivity tests and just seeing if we increase the injectivity between the holes, and that will indicate to us that we're producing these fractures networks at depth.
So what do you think has gotten people so excited about your technology? What's happened in the last year or two that people suddenly are paying attention to what you're doing?
Well, I think it's two motivations. One, the economics of mining right now. The mining industry is in an interesting position, and it's a good position, but it's like there's an increased demand, which is a good thing, but we only have a finite amount of deposits. That's just something we have to accept. And sometimes the economics of these deposits aren't as great as ones that are historically been found because of lower grades. And the mining industry, if I reflect on it, is at a point now where they need almost something analogous to the shale boom in oil and gas, something that unlocked once uneconomic resources to become economic. And for oil and gas, it was fracking at the time. And the mining industry is at this point where we need to be able to unlock these deposits and now to where we can mine them. And we know, and it's been well studied that pulse power has these really unique effects on ore. You know, we've gone over them, and could this be the technology that revolutionizes kind of a relic industry, such as oil and gas? Because oil and gas is completely different now because of that innovation in the fracking space. So I think that's where the mining industry is at is if they know that they can make it a more efficient process by less grinding and also getting more yield out of the ore because they'll be moving more rock. That I think that's just something that has to be accepted.
Yeah, I thought myself there was similarities to fracking as well. I felt the exact same way as you. So, Spencer, a lot of people are familiar with pulse power, and when that word is mentioned, they think about the technology that's used in processing. And they seem to all believe it's like a good thing, it's worthwhile. Um, Tell us about that transition from that idea of using it in processing to using pulse power in situ. How it's different and the advantages it brings as we move it in that direction.
Yeah, so historically, pulse power is deployed on the processing side where they put the ore directly into essentially water tanks and they pulse power the tanks that contain the water and that produces these shock waves and they get the other effects that they're seeking. So they have a really controlled environment and that's what breaks apart the ore during the comminution process. But, with a good understanding of ore bodies and what makes them unique because they're characterized by these veins of sulfides and oxides, why not just do the pulse power directly into the ore formation? And it seems like a much more simple approach than doing it in the processing side because you insert the electrodes directly into the ore body, which the mining industry does today regardless. And we insert the electrodes in those holes, and we discharge the high voltage electricity directly into the ore body instead of using uh, these these tanks of water that contain the ore. And that way, there's no even any change on the processing side. You just excavate the ore as you traditionally would and move it to the processing side.
That's been one of the things that has been a barrier to a lot of technologies. If we try to change the process too much, it's too difficult to do. So that's what I found interesting about this. But what about drilling those holes, putting in those, um, whatever you call them? I call them probes, uh,
Yeah, the
the
electrodes.
electrodes. How does that affect like the cycle time and the time at the face? How long do we have to condition the rock before we get uh, a meaningful gain?
Yeah, so we know this is the most significant challenge for us, for preconditioning because mining is very dynamic. You're not just having these static holes that you're continuously pulsing, and so we have to constantly be able to keep up with the blasting and mucking operations. In the lab, we're able to get the results we want, pulsing for about 20-30 minutes. So at the lab scale, we know we can do it fairly quickly. And the way we've designed our field scale devices, depending on how we configure them, we can continuously decrease the pulse power times to meet those requirements. So um, the cycle times are not an issue because we know at the lab scale it's done fairly quickly.
Yeah. One of the other things people asked me about was 400,000 volts. That must consume a lot of energy, but it's a lot of voltage, but it's not that much energy, is it?
No, because we use capacitors and we just charge up the capacitors with that minimal energy, but we discharge it very quickly. So it's not a substantial amount of energy.
And what about safety of the technology underground? Have you contemplated that and what we might need to be concerned with?
Well, I think just with blasting the same or similar safety precautions will have to be uh, implemented. Um, just with like any technology. So safety is always a priority, but there are straightforward ways of mitigating, safety concerns with pulse power.
Is there an ore that you think is most attractive for using this technology on where it could have the greatest economic impact to the process?
So, I've always favored porphyries. Um, copper porphyry ores, uh, because of the not just because of the results we've seen, but because it's the most common ore we mine today, and they just move a substantial amount of rock daily from these open pit porphyry systems. Um, so that would be what I personally would be targeting is porphyry, but we've seen a lot of, success with epithermal. We've seen a lot of success with, nickel ore related to layer mafic intrusions, but on a commercial interest, I think porphyry.
So, do you think long term the greatest impact would come from using the technology in an open pit or underground?
That's a good question. Well, I think both. I think because there's an indication that we're moving more underground because these deposits are getting deeper. If you look at the trend of discoveries today, there's clearly these deposits are getting deeper and deeper. So does that automatically indicate that the technology for its future use will have more impact on underground? Appears so. But when I think on a shorter time scale, it also has a significant impact on open pit mining, on current operations.
For a company like Eden GeoPower or any other company to succeed, you have to have the support of investors and you have to have the support of the mining companies, the customers who will eventually use it. You had a lot of support from investors. You raised quite a lot of money. If you were to describe the help you need today from mining companies, beyond cash, of course, which is always nice, what's the best way that they could assist you at this point in your journey?
So when you get to the point where you've validated the technology at a lab scale, you really start to think commercial. Like, we need to design the equipment, we need to understand the operations. What is the need of a future customer with the field scale devices? So what we have found just working with the mining companies we do now, which we had the fortunate opportunity to meet with them about every 2 weeks for over a year, which is a lot of meetings, and just giving us feedback like, this is what we wanted to see, this is the most valuable to us, this is the issues that we foresee deploying the technology, and just being able to learn from them. And that's one of the biggest supports we have because it provides guidance for us of where we're going. And to us, I think that's the most valuable is to be able to listen to those potential future customers and integrate their feedback now and not later because it's a slow process. So I think beyond funding, that's really valuable, but also giving us the opportunity to do tests at their assets. And that's another value they can provide to us, where they give us a clear understanding if we meet this KPI at this asset, you know, we know it'll be a success here because we'll have to probably tailor the technology to each individual mine. So that's another value that they provide to us.
So I understand, Spencer, you have this work that you want to execute at the Colorado School of Mines. Tell us about the different stages of it and what you would do first and where it could progress from there to eventually getting to trialing the technology underground.
Yeah, so we'll be doing pulse power tests and outcrops at the mine first. And basically, the objective there is to make sure the technology is performing adequately, that it's optimized for the geology there that's at Edgar, because it's easy for us to see, okay, we're fracturing the rock right here. Two, we'll be moving to these existing holes that they have, surface holes that they have at the Edgar mine. And there's quite a few of them, and some of them extend down to 100 meters. Um, and they're not in use. So the Colorado School of Mines basically said you can come use these wells, which is a tremendous opportunity for us because it's very expensive to drill these holes. So we'll be doing tests at different depths from 10 meters to 100 meters. And because we're doing tests at such depths, um, we'll be doing a injectivity tests between the 2 holes that we use because we have to put 1 electrode in one and 1 electrode in the other, and we'll observe if the, injectivity increases between the holes. So that tells us, yes, we created a fracture network, there's fragmentation occurring at those depths, and so we'll know that, at conditions that would be beyond a typical blast hole, we're getting the effect we want. So there's a third phase, and it's a really unique opportunity at the Edgar mine. There is a sulfide vein there. We have planned to do pulse powering directly into this sulfide vein. We've tested in the lab, and uh, it was a very spectacular effect. It basically fragmented into pieces, and we would drill 2 holes into the sulfide vein and pulse it, and we can measure if there's a change in the bond work index. We can do injectivity tests, which would be pertinent to ISL operations. So it's a really unique opportunity because they also have a drill already there in front of the vein. It's the Apache drill, and they would just drill the wells or the holes for us, and then we would do the test.
So people have a lot of confidence and understanding that pulse power seems to be working and processing. But if we can actually get it underground at the face and condition the rock right at the start, that's a game changer for mining, isn't it?
Well, yeah, I think absolutely, especially when it comes to underground, because there's a lot more control on the geometry of the fracturing, which you cannot do with with blasting. And there's all these benefits to doing pulse power underground. There's less ventilation requirements because you don't produce as much particulate in the air. So there's all these effects, and just a really unique opportunity. And we know it's one we can do fairly quickly because it's an experimental mine. We have a working relationship with the Colorado School of Mines that it's something that we can deploy in a timeline that makes sense, and those involved learn something fairly quickly instead of being years away and ironing out a bunch of logistics to get the tests going and all the issues that come with scaling.
Let's hope that we can succeed in getting the mining companies all together to support you.
I think it'll be worth it. I think it'd be absolutely worth it to get that data set in front of them. And I'm pretty confident from what we've seen at the lab scale, they would be happy to see those results as well.
I think they would as well.
Yep.
Is there any other message you'd like to give the mining industry today?
Yeah, a personal thought. I've spent quite a bit of time on the innovation side in mining. I know if the effects we see of pulse power scale, it will have a tremendous impact on the mining industry. And I want the mining industry to consider, well, is this the technology that results in a transformation to mining today? Similar to what oil and gas went through with the shale boom. And we know that it has these positive effects, and we just need to scale. And we're looking for that support to do so.
Well, you've heard it from Spencer here today. At Rethink Mining, we're trying to build a consortium of miners to help Spencer. If you're involved in it already, we're looking forward to your participation. If you're interested in joining us, get a hold of us at Rethink Mining and help support Eden GeoPower as they try to transform the mining industry. Thanks for coming in today, Spencer.
Happy to be here, and thank you so much. And
Thank
thank you to Rethink Mining.
You're welcome.